Now let us find the value of next constant, that is ak, which is given by 1 by 2 pi integral 0 to 2 pi f of theta cos k theta d theta. I can split the integral 0 to 2 pi as 0 to pi and pi to 2 pi. But between the limits pi to 2 pi, f of theta value is 0. So therefore the second term will become 0 here. Now substituting the value of f of theta for 0 to pi, we get our value for ak as ak is equal to 1 by pi. This is integral 0 to pi. F of theta is Im sin theta into cos k theta d theta. Now I can simplify this as Im by pi into integral of 0 to pi. Sin theta cos theta can be written as sin of a plus b minus sin of a minus b d theta by 2. Okay, here we are taking a as k theta and b as theta. So therefore sin a cos b can be written as sin of a plus b minus sin of a minus b by 2. So upon simplification we will get it as Im by this 2, I can take it as constant. So I will get 2 pi into, now sin theta integral is cos theta. So for this I will get minus cos k plus 1 into theta by integral of k plus 1 into theta is k plus 1. Then again sin integral is minus, minus into minus will become plus. So we get plus cos k minus 1 into theta by integral of k minus 1 into theta, again we will get it as k minus 1. We have the limits from 0 to pi. Here k is a real number, so therefore depending upon the value of k we get different values for our ak. Okay, so k can be either an even number or it can be a odd number. Now if we take any even number or odd number and try to substitute in the place of k, we can find what will be the value of ak when k is even and when k is odd. Let us substitute the upper and the lower limits for this equation. So we get Im by 2 pi into minus cos k plus 1 into pi by k plus 1 plus cos k minus 1 into pi by k minus 1 minus, again here we have a minus, so therefore this will become plus. If we substitute in place of theta 0, we will get 0. So cos 0 by k plus 1 minus cos, again we will get 0 here, 0 by k minus 1. Let us further simplify this equation. Im by 2 pi into minus cos k plus 1 into pi by k plus 1 plus cos k minus 1 into pi by k minus 1 plus cos 0 value is 1. So therefore we will get 1 by k plus 1 minus, again here we will get 1 by k minus 1. Now again in this equation, depending upon whether k is even or not, we will get the different values for ak, because cos value for pi for even values of angles and odd values of angles, for all the values will be same. So therefore depending upon our k value we can check what is the value of ak. Let us say that k is equal to some even number. Say let us say it is equal to 2. Now when I substitute 2 in place of k, I will get Im by 2 pi. Okay, in order to get a general term, I will substitute 2 only in the numerators, because cos value will be same whether it is 3 pi, 5 pi, etc. So therefore when k is equal to 2, I am going to substitute it only in the numerators. So what is the value we'll get? We'll get 2 plus 1 will be 3 minus cos 3 pi by k plus 1 plus 2 minus 1 you will get 1. So therefore cos pi by k minus 1 plus 1 by k plus 1 minus 1 by k minus 1. Now here cos 3 pi is minus 1 as well as cos pi is minus 1. So therefore this we will get it as Im by 2 pi into, when I write minus 1 for cos 3 pi, minus into minus will become plus. So I will get 1 by k plus 1. This will be minus 1. So minus 1 by k minus 1, and last two terms as it is. Plus 1 by k plus 1 minus 1 by k minus 1. We'll just simplify this. Im by 2 pi. This will be, these two will get added. We'll get 2 by k plus 1 minus 2 by k minus 1, which I can simplify as Im by 2 pi into 2k minus 2 minus 2k minus 2 by k square minus 1. Again, after simplification you will get these two 2k's will get cancelled. You will get minus 4 in the numerator. So minus 4Im by 2 pi into k square minus 1. Let us take this as equation 4. So this is the value of ak, which you are going to get for all the values of when k is equal to any even number. Okay, for any even number of k, this is the general term for ak, which you are going to get. By substituting different values of k here, we will get the different values of ak.